Alright, so we're going to do a little tutorial video over solving two-step inequalities. So inequalities are a little bit different than equations. Inequalities are going to have your inequality symbols. So the greater than or equal to, less than or equal to. You're going to see those signs instead of an equal sign. So as you're working, let's go ahead and just do one together. I think that's going to be the best idea. But let's look at our flow chart here. So the number one, the first thing you're going to do is make sure it's an addition problem by doing LCO. The second thing, you're going to get rid of the constant by adding the opposite. Number three, you're going to get rid of the coefficient by doing the inverse. And then the fourth thing, this is the only thing that's different right here than an equation. You're going to flip the sign, and notice it says if needed. So you only need to flip the sign when you multiply or divide by a negative. And we're going to look at that here in just a second. So all of the rest of these, okay, these three steps right here, they are exactly like solving an equation. So as you are solving an inequality, the only thing that's different is at the very end, okay? So let's just get going and solve this one together. So it says the first step is to make sure it's an addition problem. Well, I can look right here and I know it is an addition problem. So we're going to check that guy off and move to step number two. Step number two says to get rid of the constant. Well, in this case, the constant is 9. So to get rid of a plus 9, I'm going to add the opposite, which is a negative 9. So whatever you do to one side, you do to the other. So we've got plus negative 9 here. 9 and negative 9, they cancel. So I'm left with 4x. And I'm going to bring down my inequality sign, and nothing happens to it. And 7 plus negative 9, they are on opposite teams, so they battle. So I get negative 2. Okay? So at this point, everything is the same as an equation. Nothing has changed, and we're still working through the problem. Okay? So step number 3 says get rid of the coefficient. Okay? So that would be this 4 here is our coefficient. Get rid of the coefficient. And I'm going to do that by doing the inverse. So divide by 4. Whatever you do to one side, you do to the other. So these 4's cancel. X. I'm going to pause on this inequality sign right here for just a second. Negative 2 divided by 4. Well, actually, 2 over 4 is just a fraction, right? So I'm going to say 2 over 4. We're going to leave it like that. But we can probably simplify 2 over 4. So let's do that. 2 over 4. I can divide those both by 2, and I get 1/2. And a negative divided by a positive is a negative 1/2. So let's go for just a second to the end, okay, to this last part of our flow chart. It says to multiply, to flip the sign if you multiply or divide by a negative. So right here is what we're looking at. Did I multiply or divide by a negative number? I did not. Okay, so this sign is not going to flip. It's going to stay the same. So I get x is less than or equal to negative 1/2. Okay, x is less than or equal to negative 1/2. I want to draw your attention for just a second to this step number 4. It says to flip the sign when you multiply or divide by a negative. I can actually tell from the very beginning of the problem by looking at my coefficient. So my coefficient is what's going to either make me multiply or divide, and in this case, my coefficient is positive. So if my coefficient is positive, I know that my sign is going to stay the same, okay? If I have a negative coefficient, like for instance, had this been a negative 4, then from the very beginning, I would have known that this sign is going to flip, okay? So you can kind of tell from the beginning. I tell my students to look at the coefficient at the very beginning and make a choice as to whether it's going to flip or not, okay? So let's go and do the second example here. X over negative 3 plus 3 is greater than negative 15. So let's draw our line here. And if we use the trick that we just talked about, from the beginning, you should be able to tell something about this sign. So from the beginning, we have something here that's a coefficient. This actually also is just negative 1/3 x. Right? It's just basically they have multiplied that out, so they have x over negative 3. So our coefficient is definitely negative, which means that our sign at the end is going to flip. So let's keep that in mind. The first thing that we need to do, make sure it's an addition problem, and it definitely is. You can see right here. The second step is to get rid of the constant by adding the opposite. So to get rid of a positive 3, I'm going to add a negative 3. Whatever you do to one side, you do to the other. So this guy, these cancel. Okay, I'm left with x over negative 3 is greater than, and negative 15 plus negative 3. They're on the same team, so they become negative 18. All right, so done with step 2. Let's move to step 3. Get rid of the coefficient by doing the inverse. Well, the variable is being divided by negative 3, so the inverse would be to multiply by negative 3. Okay, whatever I do to one side, I do to the other. So these guys cancel. I'm left with x, and then I need to do some little scratch work here. 18 times 3, 3 times 8 is 24. That's 3, 4, 5. So I get 54. And negative times a negative is a positive. And then let's look at our sign for just 1 second. We said step number 4, when you multiply or divide by a negative, your sign flips. So I did just multiply by a negative number. So instead of being greater than, my sign is going to flip, and it's going to be x is less than 54. Okay? Again, I really could see that from the beginning by looking at this coefficient that was attached with my variable. All right, let's do the last example here. 17 minus 2x is greater than or equal to 2. Okay, 17 minus 2x is greater than or equal to 2. So let's draw our line. And I'm going to say, I want you to think for just a second if you think this sign is going to flip. This one might be a little bit more tricky because we need to do one specific thing before we actually start the question. So we need to see if it's an addition problem, and right now it is a subtraction problem. So the strategy that we use LCO. So you leave the first term, change subtraction to addition, do the opposite of 2, which is negative 2. So at this point, you probably can tell that this coefficient is negative. So I would say definitely when we get to the end, our sign is going to flip. Okay? So same thing as regular equations. Let's go ahead and get rid of the constant. So the constant here, they're actually in an opposite order. Constant is 17. So to get rid of a 17, I'm going to add a negative 17. Whatever I do to one side, I do to the other, so plus negative 17. So I'm left over here with negative 2x is greater than or equal to, and 2 plus negative 17 leaves me with negative 15. Okay? The next step says to get rid of the coefficient by doing the inverse. So the inverse of times negative 2 is going to be divided by negative 2. So whatever you do to one side, you do to the other. These guys cancel. Okay? So I'm left over here with x. And because I divided by a negative number, my sign right here, it's going to flip. So instead of being greater than or equal to, it's actually going to end up being less than or equal to. And then 15 divided by 2. So we need 15 divided by 2. We can leave it as a fraction, or we can make it into a whole number with a decimal. 2 goes into 15 7 times, and that's 14. So we have 7 and 1/2 that's left over. So we've got 7 1/2, and a negative divided by negative is a positive 7 1/2. So we're left with x is less than or equal to 7 1/2. The biggest thing for you to remember is to look at the very beginning of the problem. Again, if you see a negative coefficient, I would go ahead and circle your sign, make sure somehow that you remember to flip it, okay?